So now what we're going to do is we're going to imagine that we have a false quadratic, okay? So imagine that I have something that looks like this. X squared minus 14 minus 13x plus 36. Now, if we were factoring, we would need to look for two numbers that multiply to add to negative 13 and multiply to positive 36. So I'm just going to write that down. So we're looking for something that adds to negative 13, but then multiplies to positive 36. Now, the big hint here is that this term here is positive, so that we either have two positive numbers or two negative numbers. The hint that tells us that we have two negative numbers is this middle term in the middle. Because this is positive, because we need two negatives or two positives, we check the middle term, and we notice that the middle term adds up to a negative number. So therefore, both numbers must be negative. So let's go and calculate the following. So normally we'd look for two numbers that multiply to 36, but then add to negative 13. So both of my numbers need to be negative. So I'm going to say that my first number is negative 4 and my next number is negative 9. Okay, so negative 4 plus negative 9 gives us negative 13, which is good. And then we have negative 4 times negative 9 gives us positive 36, which is what we are looking for. Now that we found those numbers, we can say what our factorization is. So we have x minus 4 and then x minus 9 as our factored form. So now imagine I give you something that looks like this. This is our false quadratic. All right, so imagine I have this. X to the 4 minus 13x squared plus 36. Now, this does look very similar to this and this. These two parts match, right? But they're not quite right. So in order to make our work on our false quadratic look similar to what we have on the left, we have to do the following. We have to substitute x squared and let that be s. So that means x to the 4 is equal to x squared. So it's kind of like we've translated it into something that looks like this. So now we're using s instead of x. So we have the following. So now we've just translated our equation into s squared minus 13s plus 36. And because it now looks very similar to what we had before, we know that the factorization is going to be, well, s minus 4 and s minus 7. Okay. No, s minus 9. So now that we have that, we can back substitute what we know. But s equals x squared. So let's substitute that back. So we have our original equation is now x squared minus 4 and x squared minus 9. Now both of these individual brackets, this one and this one, can be factored individually because they are difference of squares. So we end up with something that looks like this. X minus 2, x plus 2 for the first bracket. And then for the second bracket, we're going to have the following. X plus 3 and x minus 3, because it is a difference of squares, and 9 is a perfect square and 4 is a perfect square, and we're done. And that's what I'm asking you to do in the question that I posted online just now. So go and do that for me, please. Those 3 questions should be a little more difficult than you know, but you can do them.